thought I'd make one more help video for this section on exponentials of various forms. Again, another problem, and I picked this one at random, but it's about a value of 8,500 grows exponentially so that it doubles every 9 years. Where would we be after 23 years? So, we want to come up with an equation. I have an initial value of 8,500 and it doubles. So, I'm multiplying that by 2. That's easy enough. That's the doubling part. The tricky part is it happens every 9 years. So, at 9 years, I want the power to be 1. So the trick here is if when t is 9, you want the power to be 1, you actually have to have the power as t over 9 if you think about it. Right? If t is 18, you want to double twice because it doubles every 9 years. So 18 divided by 9 equals 2. So you have to kind of think outside the box here. And that's the value, right? We can call this f of x or f of t, I guess f of t. So I'll call it f of t. You call it a for amount, whatever you'd like. But that's the equation right there. And that's really... that's the whole problem, So any of these things about doubling or tripling, that's going to be the base of your equation. So now they want to know after 23 years, well, you're just plugging in 23, right? F of 23. Oops. So it's 8,500 times 2 to the 23 over 9. And 23 over 9 is, it's about 9.5. I'm sorry, it's about 2.5. So you're going to double a couple of times and then half of a time. But what are you going to do? You're going to plug that into your graphing calculator. And to the nearest hundredth, you get a pretty big number. I'm just going to read it off my calculator. 49970.972. So if we round that to the nearest hundredth, it's 0.97. Again, I hope when you're doing these videos, you're kind of following along with a paper and pencil as you work them out. So again, that's another example of an exponential growth problem. I hope that helps.